let's look at this first one on your sheet. So today I really want to stress the pictures that we draw with these problems. Because if you can't get the picture, then it's kind of tough to get the math or figure out what it's asking you to do. So let's really focus on getting the pictures down and doing what it asks. So the world's tallest smokestack at the International Nickel Company casts a shadow that is approximately 1,580 feet long. So let's first draw our smokestack. That's our smokestack. And the shadow it casts is 1,580 feet. And then the sun is somewhere, and the angle of elevation they tell us is 38 degrees to the top of the building. They want to know how tall is the smokestack. So we can assign that a variable. We can say that tangent of 38 is equal to opposite over adjacent. And what do we get x to equal? Is it just one? What? 0.43, yeah. It's okay. So about 1,234, yes.
Wouldn't that be the angle of elevation from the ground?
But it's talking about angle of elevation, so we know that it's from the ground up.
But it says measured from the horizon.
The horizon is the
Yeah,
ground.
in this one it is the ground. Just, I know, and it can be confusing, but it's angle of elevation, so we know that it's from like here looking up. Good question. And that's feet. What?
Nothing.
Okay, moving on. Let's try this one. It was 1,234 feet.
What is the angle of depression? I didn't get it right. No, then you can
Okay, so a woman is standing on top of a building at a height of 5 miles above the ground. This is a tall building. I don't know what I was thinking when I wrote this problem, but we'll go with it. So our building is 5 miles tall. It's huge. And there's a woman on top here. That's her. The distance along the ground from the building to the closest gas station is 9 miles. So we can say that that's our gas station. And they're telling it's 9 miles. So we can make our triangle like this. But what is the problem asking for? It's asking what is the angle of depression from the top of the building to the gas station. So they want to know, remember when we do angle of depression, we draw like that straight view out? And our angle of depression is right here, right? So this is what we want to find. But before we can find that, don't we need to find this angle? Yes. And how would we do that? If we say that's theta, couldn't we say that tangent of theta is equal to opposite over adjacent 9 over 5? But we have to undo that. And doing that, we say tangent inverse of both sides. So theta is equal to tangent inverse of 9 over 5. And you should get about 61 degrees, approximately 61 degrees. Right? So that's this angle. Are we done? Is that our angle of depression? No, we got to take 90 minus because this is a right angle and we want this angle now. So 90 minus 61, 29 degrees is our angle of depression from where that woman's standing down to the gas station. If you could do the first one and the second one, those are both R2s. That would be like an R2 question. Okay, let's move on to the third one, our third and final review one. This 45, it's kind of worded badly, so this should be like the shadow of the building. Good job. Okay. Does anyone want a little more time, or should we go over it? Okay. So let's go over it. So from a point 45 meters, so like I said, it was the shadow from the base of a building to the top of the building is 49 degrees. So here's our building. Again, we have a building. And the shadow is 45 meters. And the angle of elevation is 49 degrees to the top of the building. So that's this angle, 49 degrees. Then it tells us that there's an antenna on top of this building. So let's say that's our antenna. We're still from the same point, but now our angle of elevation, this should be it. Our angle of elevation is 53 degrees. So what we need to do is this whole distance we can say is x. We can say that our building is y and this is z. And we're trying to find out z because it says, what is the length of the antenna? So to find z, we would just say x minus y is equal to z. So we need to find these values. So to find the height of this building, what do? How do we find the height of the building? Can we say tangent of 49 is equal to y over 45? And what does that give us y to equal? 45 is about 52 meters is what I got. And then we have to find out, well, this whole distance, and the whole distance is x. So we can say that tangent, and now our whole distance, that's with this angle, with 53 degree angle. So tangent of 53 equals x over 45. And that should be about, x should equal about 60 meters. So I got 59.7, so about 60 meters. Tangent of 53 times 45. So now we have the total height of the antenna and the building, which is 60. And then we have the building. So if we say 60 minus 52, we get that the antenna is about 8 meters. Did anyone get that? Yes. Yep. It will tell you, so like, the problem will tell you on the test. It will say like, round your answers to the nearest hundredth or the nearest tenth. It will tell you. Okay, so let's move on to the new stuff. Today we're going to be talking about a bearing. And a bearing is the angle in relation of like going north and moving clockwise. So a bearing, when we're finding a bearing, we're finding like the degree measure, and that's like how far we have to travel. So to break it down and explain it a little bit better, we're going to talk about a nautical mile. Who knows what a nautical mile is? Marcus.
A mile is like in the circumference of the earth.
Yes, that's perfect. So then what kind of professions would use a nautical mile? A sailor. What about a pilot? Yep, sailors and pilots. And the reason they can't use a mile is because it's more circular. It's not like straight shots. So a nautical mile is using like distance, like circumference-wise. So to find, to like get the nautical mile, this is what they did. They cut the earth up. And they, in the middle, they went 1 minute. So you know how we have degrees, minutes, seconds? They had an angle of 1 minute. And when they went out to the circumference of the earth, that distance was 1 nautical mile. So the reasons for using a nautical mile is because the earth is circular. So it wouldn't make sense to use a mile because I have a ball. It will help me explain it. So like on a ball, if you have a point here and a point here, do you agree that this distance would be longer than if we just did a straight shot through the ball to the 2 points? So that's what a nautical mile is. It's like the circumference or going around something. And that's why we are going to use nautical miles with these problems. So I found it. Where's my pen? 1 mile is about 0.869 nautical miles. And when we're using these problems or doing these problems, you can say nautical miles like NM is the unit of measurement, or capital NM. And then knots is a nautical mile per hour. So when we're talking about miles and we say miles per hour, the knots is the nautical miles per hour. And something interesting, since the earth is circular, there's 360 degrees total around it. And each degree can be split up into 60 minutes. So what's 360 times 60? Who can do it? So the distance around the circumference of the earth is 21,600 nautical miles. So I thought that was kind of a fun, interesting fact. And you won't have to do this on the test. I just thought it would be worth taking the time because I never knew that this was how they got a nautical mile. So I thought it would be interesting to share that with you all. So a typical problem looks like this. This is number 4 on your sheet. So with all of these problems, it's going to be in relation to north. So we're always going to want to start using that. North. So a ship leaves port at noon and has a bearing of 223 degrees. So, starting at port, he's facing north. We have to go 223 degrees. So from north to east, what would that be?
90.
And then down to south? So 90 plus 90 is 180, right? And then what about to here? What's that? 270. So do we agree that 223 degrees is like about there? A rough estimate. So we can draw a circle. And our bearing, that's this. That's how far. So they were facing north and they went 223 degrees to travel in the direction that they wanted. So this bearing, B equals 223 degrees. So now we want to know this distance. And an important formula that you're going to need is distance is equal to rate times time. So their rate is 22 knots because remember we said that was the nautical mile per hour. So we have 22 times, now our time. How long did it take them? They started at noon and then it was 8 o'clock p.m. So how long is that? From noon to 8 p.m. 8. So 22 times 8 will give us our distance. 22 times 8, 176. So that is this right here. 176. Now the rest of the question says how many miles south and how many miles west did they travel? So we don't have quite enough information. So what we need to do is we need to draw a triangle. All these problems are about drawing a triangle. Find the triangle. So this would be the distance west, right? North, east, south, west. And this would be the distance south. But before we can find these, we have one side length. But shouldn't we find a degree so we can use our trig functions? Couldn't we find that angle right there, the red? Yep, it's right here. It should be. So west and then south.
Constantly going southwest
Overall. But they want to know, okay, how many miles west did they go and then how many miles south did they go? So we can draw a triangle and look at it like that. So we said that from here all the way to here was 270. So we can say 270 minus our bearing, 176. And what does that come out to be? Oh, 223. Sorry. Minus 223. And that's 47 degrees. So 47's right in here. And now we're ready to look at our triangles, aren't we? So south, let's first do west. So we can say that west would be equal to, so this is our angle and we have this side. What trig function should we use to find west? Yep, so we can say cosine of 47 is equal to W over 176. And what does that come out to equal? $120. So 120 nautical miles. So they went 120 nautical miles west. Now for the last part of the question, we have to find south. How many nautical miles south did they go? And that would be south is equal to, so now we can use sine. So we can say sine of 47 is equal to S over 176. And what does that come out to equal? What? 128. So that'd be 2 answers for that problem. Base things to remember here are distance equals rate times time. The bearing is in degrees and it's in reference to north. Always starting north and going clockwise. And then taking what you know and then plugging it into a triangle and figuring out what you don't know. Okay, second kind of problem. plane is 145 miles north and 75 miles east of an airport. If the pilot wants to fly directly to the airport, what bearing should be taken? So when we see bearing, we know that our answer is going to be in degrees, because that's going to tell us how many degrees would you have to turn from north to get going where you want to go. So let's say, well, first thing first, draw that arrow with north. It's always our starting point. Then we're going to say the airport's down here. And we're going to say it's down there because the plane is 145 miles north. And it's 475 miles east. So this is where our plane is. The plane is 145 miles north and 75 miles east. So now the pilot wants to fly directly to the airport. So he wants to go like this. He doesn't want to go 75 miles west and then 145 miles down. He just wants to go straight there. So he wants to know, if he's facing north, what bearing, how many degrees should he turn so he can head straight to the airport? So we're trying to find this. Remember how I said this is bearing? North, from the north going clockwise? So we need to find this angle. How do we do that with what we're given? Is it possible? Yeah. So we first can find this angle. And we can find that angle by saying tangent of that angle is equal to 145 over 75. Yep, so then we do inverse tangent on it. So what does that give us? So should we say 62 degrees? 63 degrees. So that's how we found this angle. Now, but that's not the angle we want. We want the bearing angle. So what, from all the way here, what's that degree measure? From north all the way to west, what would that be? 270. So 270 minus 63 is 207 degrees. So that means that the pilot, if he's facing north, he has to turn 207 degrees, and then he can head straight in that direction, and he'll hit the airport. What? Yeah, your test will tell you how to round. But you wouldn't miss it by much. Any questions on that? It's important to always draw our arrow and move clockwise. What? Oh. The last one. This would be an R3 one. So, before I start, I'm just going to draw my north because I think it's so important. The 2 Coast Guard patrol boats leave Cape May at the same time. One travels with a bearing of 32 degrees, 30 minutes, and the other with a bearing of 42 degrees, 12 minutes. So, before I even move on, I'm going to convert these just into degrees. What do those become? 32.5 and 42.5. Good job. How'd you do it so fast? Or were you working ahead?
No, minutes is just.
Oh, half, yep.
At 60 minutes in a degree, so it's half in that.
Yeah. So those are angle measures. If they travel at the same speed, approximately how far will they be when they are 42 statute miles away from Cape May? So we'll say this is Cape May. Right there. Cape May, CM. And the first one has a bearing of 32.5. So we'll go here, and this is 32.5 degrees. That's our first dude. He's right there. Our second guy is 42.2 degrees. So we'll say he's right about there. And that's this whole angle, which is 42.2 degrees. So now we are trying to find, what we're trying to find in this problem is how far these two guys are away from each other.
Wait, what's the difference between statue miles and
Yeah, I would just say it's normal miles.
okay.
As in not referring to nautical miles. And then we also know these side lengths. They're telling us they are 42 statute miles away from Cape May. So that means that from Cape May, they're each 42 miles away. So if we want to find how far they are away from each other, we can say that x is equal to the rate multiplied by our angle. So they're traveling at the same speed, so our rate is just going to be 42. We don't have to convert that at all. But we want to multiply that by our angle. But this is the angle we want, right? Because this is like the kind of like the triangle we're working with. So this is the angle we want. How would I find that? Yep, 42.2 minus 32.5, which gives us 9.7. So this degree is 9.7. Then one other step they want us to take is they want it in radians. They don't want it in degrees. So before we plug it into here, we got to put it into radians. So what's 9.7 times 0.017? 59? 49. 1649. I got 1693. You got 1693, 0.1693?
Yeah.
Depending on how you round. That's what I got. Am I wrong? 7 times 0.017. 0.16, oh, it is 149. Maybe when I was doing it, I was working with different numbers. Oh, well, it's 0.1649. So we plug those radians into our equation. And what do we get x to equal? And what would that be? Is that miles? Or what is that? It's on the circular path, so what would that be? Nautical miles. I think these are fun. A lot of steps, though. You do differently? Not much of a difference, though? Okay. I would, yeah. So, yes, Ian. Okay. Well, depending on how you round, too. Yes, Ian. That's, for these type of problems, I'm supposed to just tell you that's what it is, because it's like, that distance is rate times time. Remember how we said that? And our time here would be the degrees, or like how far they've traveled. So this was their rate. 42 is their rate. And then you're timesing it by like how far they're going in degrees. So for these types of problems, you just want to remember that you want to go like the rate times the degrees. I don't know how to, yes. What? Yeah, so you might call it, so yeah, some of you have seen it like S, so does that make more sense? The SOAR is equal to the, yep.
We had R as radius, not rate.
Okay.
Radius, because
Oh, yes. So then the rate, which is 42, or the radius, which is out to the circle, times theta. Yep.
Okay.
Yes. Yes.
So I got 9.7 degrees in the triangle, you know.
Yep.
Times by 0.01.
That's converting it from degrees to radians. Yep. Any others? Okay, so let's look at the homework.